Now we have an interesting option called, now how can I get something like this shape? So if I apply the sweep tool, I can only change this profile and take up to here, but the interface is also rectangle. If I apply the loft tool, it's directly coming and hitting me. So I will show you what happens when I apply the sweep tool. So we have the profile, we have the path. So this is the sweep tool. So it's not taking the end face. If you apply the loft tool, what happens? It just connects without taking this shape. So now we have to have a combination of loft and sweep to get this special shape. So this is a loft plus a sweep. So loft plus a sweep. So some softwares they have a special separate tool to carry out this operation. But in SolidWorks we don't have that different. There's no different tool. So we have an option on the loft called center line parameter. So we have to give that middle center line as the path. So you have to click here and click on the middle center line. Now it will take that path correctly. So we are getting sweep plus loft both together, and we can enable the thin feature if you like. So I will enable thin feature 1 millimeter. So easily we can generate something like a manifold shape. So very easily you can get this kind of a shape. So I applied center line parameter. So remember that tool also. There's a tool called center line parameter. Now this is another option available on the sweep. So this is called close lock. So this is a thin feature. So this is a close lock. So if you enable this button automatically, this will close. So this is actually not a very good tool option. So we have a sweep lock here. So if I want to close this lock, normally we should draw these other profiles. But there's an option called close lock. So what happens here is software tries to close it automatically. So he will not, it will not close it properly. So you can see it's not properly closed. So if you want to have a properly closed one, better you draw your own profiles and get that correctly closed. So don't use this option. This is not a really a good option. Sorry. Now we look at this one also. how can I add the section in a already existing model? So if you feel that you need more shape in the middle, you can add the loft section easily. So without going to the basics again, I can click on this model and add the loft section. So these tools may not be really accurate, but we will teach you. So I will get this 1064. So already they have drawn a shape using these sketches. So I feel that in the middle I need some additional shape. So what we can do is we can right click on the place we need the sketch, and there's a tool called here add loft section. So when you right click on the body, that place is highlighted now, and you can see a section has been profile has been created for you. Now this line uh, can be changed. So I can take it out a little bit or put it inside, and now there's a new plane created. So you can see the third sketch has been, sorry, sixth sketch has been created by me, and your profile has been changed. Otherwise, you have to delete all these things and do it from the beginning. So this tool will help you to do it really quickly, but it may not be really accurate sometimes. So you can right click and go get a section and click on this thing and say put it inside a little bit. Sometimes it may not generate correctly, so this can be done. So I added another section. So that is another option available. So right click and get this tool. Similar to sweep tool, we have the loft cuts also. So the same theory will be applied. So you can draw the different profiles and apply this lofted cut tool also. So I may not go through this. So it's easy. So similar concepts like sweep cut. So we have done this 3D sketches also, and there's a tutorial from these 3D sketches. So if you look at our tutorial set, we have the second tutorial based on this 3D sketches. So you can try this thing and try to draw this frame. So all the measurements given. Normally, we don't need to draw the full path. We can draw half of the path and get a 3D sweep here and get the mirror. So they have applied the 3D mirror here. So you don't need to draw everything. Just draw half of this and get the 3D mirror to the half of this model. So you can try that at home. So we will look at the last topic under our modeling. It's called curve techniques. So I talk about some guide curves and how to draw additional lines, curves, and all those things. So if you want to draw your own springs, spirals, so for an example, if you want to do this kind of a tutorial, you need to know how to draw these spiral shapes. So these shapes, how to draw the spring shapes. So these things are done from the curve techniques. So we will look at the theory behind that now. Any questions after this point? Any questions about the sweep tool and the lock tool and the 3D sketches? So I will start the projection curves technique. So we will open this file called 1075. So here already there are two sketches drawn. So the first method is called project curves. Project curves means he will use the already existing curves and generate the third curve. So for an example, he will use these two curves and generate a third curve from projection. So I will do it and show you. So enable this tool project curve, and it says sketch on faces, sketch on sketches. So I have two sketches at the moment. So we will use the sketch on sketch method and click on this sketch and this sketch. He will generate the third sketch. So if you look at from this side, this is the shape I am getting. Look at from the top side, this is the shape I am getting. So he is projecting the lines upwards and to this side, horizontally and vertically is projecting. And those intersections are again connected from a curve. So you can see this shape as well as this shape, but it's a in 3D view, it's the different shape at all. So we can press OK. So this can be used as a guide curve in sweep tool or loft tool. So this is called projection method in curves. So we had another option called sketch on face. Now sometimes you may have this kind of situations. So you need to draw something here. Say you need to have a cut here on the surface. But this is a curve, so you cannot draw profiles here. You cannot apply normal cut tools. So you have to draw something like a curve in a different plane and project onto this one and get the path. So I will show you how it works. So when it comes to complex drawings, you need these techniques. So for an example, this one. Now someone wants to have a cut here, swept cut. So we can't draw anything here. So this is not a flat surface. So sketching tools will not work. So I cannot draw new curves here. So we have to draw it in a separate plane, this line, this curve. Then we can project that curve onto a face. So this is the tool, sketch on faces. So this sketch can be projected onto this surface. So the direction is wrong, we have to flip it. You can see it's projected. So this is projected. So otherwise I cannot draw anything here. So you have to understand if this is not a flat plane. So you cannot project, so you cannot draw, so you have to project it. So once I project it, I don't need these planes anymore. We will hide them. Now I got the correct path. Now if I want, I can draw a sweep cut. So we have to have a sketch here. So plane was drawn. Then on top of this plane, we can draw our shape. And we draw a certain rectangle shape. So when it comes to drawing the rectangle shape, you can see my snapping tools are not working. I can't get the center point correctly. So if I try to get it manually this way, when I zoom it, it's wrong. So you can see there's a gap. So the snapping is not working in this situation. So what can we do? Now snapping is not working, so we can't use this method. So I hope you understand. So if I want to get it exactly on this point, snapping should work. So snapping is not working. So if you get something like that kind of problem, you have to come here and enable this 3D sketch mode. So we have done this a little bit earlier. So 3D sketch mode, then now you may try to draw that object. So now the snapping tool works. So you can see it's working, but it's not drawing in the correct plane. So there are issues at the moment. So we have to select this plane, and after I select the plane, I have to go and enable this tool, not the 3D sketch. There's another tool called 3D sketch on plane. So if you just come here and enable 3D sketch, it's not selecting this plane. So you have to select the plane and come here and enable 3D sketch on plane. So that's going to work now. So then we can draw our shape here. Now the snapping is working. Coincident symbol like this. Okay. Excellent. So I hope you understood. Then you can apply a swept cut. Sketch profile. So this is the sketch. Path is this. Okay. So nicely I can cut it like this. So you can see how nicely we can do if you know the techniques. Otherwise, you are in a big trouble when it comes to drawing cuts or drawing solids here. So there will be big issues. So I started with the basics. So we need to know the projections. So I had something like this. I hope everyone can draw something like this on a plane now. Then we project it, sketch on faces onto this face. Direction is reverse. Now we can hide these things. So then we have to draw a plane here. Done. So click on this plane and go to 3D sketch on plane. Otherwise, problem is the snapping will not work. So I can use the snapping now correctly and draw it. Then exit. Then you can come here and apply a sweep or a sweep cut. Right. So this is the outcome. So any questions? Let me know. You can try it and see. I will proceed to the next option. So we have splitting tools available in SolidWorks. This is really important when it comes to simulations. So we have, say, this is a sphere, so we can split the sphere into pieces and apply different boundary conditions. Here we can apply a load here, we can fix this side, or we can paint in a different color. So I will show you how the splitting tool works in SolidWorks. I think there are some issues with my files. So if you are not getting the previews, there may be problems with your part files. Let me know if you cannot open your part files. So I have to open this 1083 part file. So if it is not opened, you tell me. So this is a easy drawing actually. You can sketch using a revolve tool. So quickly I can draw this sphere. Now there is a plane drawn cut in this sphere. So I will show you how the split tool works now. Split lines. There are three ways of splitting a surface. We will start with this intersection, easiest one. If you use the intersection method, you need to just select the splitting face and the planes. So this is the plane to cut. So this is the plane to cut. So this is the plane and this is the body to cut. So you can see it was cut now from the face. So now this has two faces. So the idea here is, if you want, you can color this. Say I just give a color, not for the entire body. This way we can give a different color. So it's a single body still, but I have split the face. Or on the simulations we can apply a load. So I will next day we will start this one a little bit. I may not go through in very depth, but we will have introduction for our assignment also. So we will I will show you how to apply a static test quickly. So we can say fix this geometry this side. This side is fixed now. So it's a fixed geometry, and I will apply a load to the other side. So we will apply say 500 newtons, and I will give a material. Now this is the usefulness of this one. So I have splitted the face and applied this is fit. This is 500 newtons. So I just apply a simulation without doing a lot of optimizations. So now we can apply a simulation and see whether this is failing or not. So it will generate the stress results. One is a stress result, so we can get displacement results, we can get strain results. So this is the useful usage of this splitting tools. So we can split the model into two or several areas and apply different boundary conditions, different colors. So I hope you understood the usage of these splitting methods. And for the molds also we need to split the faces. So we will look at them next day. Uh, so we have different ways of doing the splitting. One is in-house, the other one is projection, third one is intersection. So I use the intersection method. So I will show you how to use the seal out method. So earlier I used the intersection method. Then we have two other methods. One is called seal out. So seal out, we have to give the direction of tool. Say we can select this one and the face to split. So this is the face to split. So what happens here in chill out is always it will split from the middle. It doesn't care about the plane location. It stays the maximum radius. So it's splitting from the middle. So if you look at the other method, projection method, we have the sketch to project. So projection method is not going to work here because we don't have a sketch faces. So seal out is always cut it from the middle. If you take the plane outside, yeah, we take it somewhere here, and if I apply the seal out now, result is same. So seal out always take the maximum diameter in this case. So I showed you how to use the intersection method, seal out method. Any questions? Let me know. And this is example for projection method. So here we don't have sketch to project. So we take that example. This one 1085. So I have a sketch here. So I have to project that. I I can use the split line tools and get a projection onto this. So projection, this is the sketch, this is the base. So check the direction, direction should be downward. Okay. So what happens here, I projected the lines and I got two surfaces, separate surface. So you can apply different boundary conditions, apply different colors to this. So now here also we have this project method, but that will not split the faces. Now if you use the sketch on faces, almost similar, but I got the projection, but it won't split the face into two. It won't split the face into two. So that is the big difference between just curve projection and split projection. So this projection is splitting the faces. This projection is just project the curves onto the face. So there is a big difference between these two methods. I hope you understood the difference between split projections and normal projections. So I can apply the split projection. Say just apply. Okay. Uh, when it comes to simulations, I can apply a load density. So we will apply a thermal load this time. This is 100 kelvins, 100 Celsius. This is 50 Celsius. Then I have to give a material. Then we will just run the simulation without optimizing. So this is the temperature distribution. So I started with 100 Celsius and ended up with 50 Celsius. So this will show me the temperature distribution from this space to this space. So you can see how the tool works. So this is why we learn these techniques in the modeling. So any questions, let me know. So this is another example for intersection. So if I show you that example also, so we need to split this into phases, different phases. So you can use this kind of a front plane and split it using the intersection method, front plane, and these phases can be easily split. And you can now apply different colors, different boundary conditions. This will not separate the body into several bodies. It's still a single body, but you have different properties. You cannot apply different materials here and there. It's a single material, single part. Next tool is called composite tool. So why we need composite tool is to connect more than one curve. So for an example, if you don't know about the 3D sketches, so I have taught you how to draw the 3D sketches. Some people may not know about the 3D sketches, so they want to connect two or more curves. So they have to use composite curve techniques. Now, for an example, if You just say draw a 3 point arc and sit, and sometimes you may need to draw another uh, sketch on sketch connecting to this. Say I will just draw another one, something like this. So these are drawn in two separate sketches. But if you try to apply a sweep tool, it won't work. Now it will work until this point because it's not a continuous sketch. So if I try to apply sweep, I will just apply circular profile, select this. So sweep will only works up to here. It will not take this one because sweep cannot take more than one curve. So only one curve is allowed, one sketch. So what can we do now? So sometimes you may have cases like this. So you have to use this curve tools and get the composite curve. Combine these two curves and take a composite curve. So for the composite curve you can apply the sweep tool. So you can see now it's working for the composite curve. So this is the application side. So this is a 2D, but sometimes you may have 3D curves also. So you can connect all these things easily. So we will look at the next option, how to draw curves using tables. So sometimes you may get coordinates from somewhere else, so some from a scan. So you can input those coordinates into SolidWorks and draw complex curves. So I will show that method also. Now I have this option called curve through XYZ points. So we can use a table. Say first point may be 0, comma 0, comma 0. Second point may be 10, comma 10. So you can see the curve is now drawn. Say 20, comma 10. Likewise, I can input the values, and we cannot have identical points, something like this, and get a composite curve. So get a curve. So otherwise, what can we do is we can import it from a notepad or something like a SolidWorks table, SolidWorks curves. So you can save these coordinates for the next future use also. So if I save it, I will just save it in desktop. So this is now saved in desktop. So these are the coordinates. So if you want, you can use this for your next project. So I will just change these values. Now, if you get this from a scan or internet, those coordinates like a point cloud can be imported to our drawing. So I will try to import it. You can browse the coordinates, SolidWorks curves, this one. So automatically the table will give you. You can add additional things also. Press OK. So this is my new curve. So this is like importing from scanners or point clouds. So remember this technique also. So you can create a table here or import the coordinates and draw a curve from the coordinates. Then there's another one called curve through reference points. Now, if you have points drawn in your model, that can be also used to create curves. Now, we will sorry. So, if I have 2D or 3D points, now these points are drawn by me, or we can get it from somewhere else, and these points can be used to create a curve using this method. Curve through reference points. Now we can select these points and generate a curve from that points, those points. So now we can use sweep tool and get the profile or whatever the thing we want. So this is another way of doing curves. So I hope you understood up to this point. Then we have the sprints and helical tools. So if I want to draw a sprint or a spiral, these kind of shapes, we have to use these curve tools. So we will start with an example and show you. Now, if I directly go here, it will not show me anything. So I have to exit from sketch mode. So better you go to sketch mode and draw your sprint diagram. So this is my sprint diagram. Then we come here and enable the helical spiral tool. So we need to have a base feature to start this base circle sketch. So now this is started. So we have different ways of giving inputs. We can give the pitch and revolution. We can give height and revolution. We can give height and pitch. Or we can do spiral shape. So I will give pitch and revolution. It's a constant pitch. So the pitch value is 20 millimeters, and I have say 6 revolutions. So this is my spring appearance. So if you want, you can reverse the spring also, and we can have clockwise or anti-clockwise direction. Uh, Start angle is can be changed. So if you change to 0, it's starting from here. So you can see how start angle changes, and then it comes here. And if you want, you can have a tapered shape also. This way, outward taper or inward taper. So press OK, you will get the sweep. So the initial circle you have drawn is now not going to be visible. So this is my helix shape. Then if you want, you can apply sweep. I will try to get the circular profile. Diameter is given. So quickly we can design something like this. So we can give pitch and revolution, or we can give total height. So total height and revolution. So these are not enabled. Or else we can give height and pitch. So different inputs can be input. Then we can have variable pitch also. So I will give different values for pitch. So starting pitch is 20 millimeters, ending pitch may be say 40 millimeters. Then we can have middle values also. Say something like uh, 30. In the middle, sorry, this is 25, this is 30. So in 25, this is revolution 4, this is revolution 6. So I'm changing now. So starting in the starting it's 20 millimeters. So after some time it becomes 25. So we see 30. In the fourth revolution, the pitch becomes 4. Sorry, 100 millimeters. Sorry, 30 millimeters. Then in sixth revolution, pitch becomes 40 millimeters. So you can see this is very close to each other. Here it's going to be apart. Here the gap is big. So that can be also given and achieve something like this. So the pitch varies. So we can add more points and change the pitch. Say I will have 60 here. So you can change the shape as soon. Then you have the last option called spiral. You can get something like a mosquito coil shape easily from the SolidWorks tool. So I can apply sweep tool for this. First we have to get the plane created. Then on this one we can draw a center rectangle. So here the snapping is not working. So if the snapping is not working, always come here and select the select the plane and select this 3D sketch on plane. Now it should work. Now I can apply sweep sketch profile. This is the sketch. So you can quickly generate a mosquito kind of a shape, coil shape, very easy. Let me know if you have any questions based on these tools. So we have covered all these things. For your assignment, you may need these things. So get used to the software. So try to do this tutorial also. I may not do all the things with you. So we have the spring here and we have this hook here. We need to connect the spring and the hook from the composite tools. So we can draw the spring shape and this one separately and connect them using the composite curve and apply the sweep tool. So that's what they have done. So try it by yourself and any questions let me know. And this is also a very good tutorial. This is about the lofting tool with the center lines. So I don't have time to go through these things. So you try by yourself and get used to the software. So these kind of questions normally we give to our students in our assignments. So better you go through these things and have a good idea about how to draw these things. Uh, so now this is the end of our modeling. So I don't have time to go through the drawings and the assemblies because I have to start with the simulation techniques. So I just covered the base, only the necessary areas in modeling. So we didn't cover these pattern techniques. We didn't cover draft tools. We didn't cover boundary bus base, and we didn't go through these other features like passing features. We didn't cover. So there are a lot of areas available. So we didn't cover these free form, deform, indent, flex. So those things I didn't cover. So those are the things I didn't cover in under modeling. So I'm not giving tutorials based on those things. The tutorial is based on the things I told you in the taught you in the class. So next day, please have the simulation ready. This one ready for your in your computer. Flow simulations we will do later. So first 2 weeks we will do structural simulations, and the last 2 or 3 weeks we do the flow simulation. So have them ready next day. So we will start simulations, and your assignment will also be given very soon. So I'm still preparing it. So we will meet next day. Uh, Thank you for participating in the class.